So if you have a problem with the recorder, please refrain from speaking because it has started. So this is the second interim of the LPWAN working group for this year 2021. Welcome to the group. This is an official IETF meeting, so the best practices apply, in particular best practice regarding patents and IPR. So if you're aware of any IPR that is discussed today, please let us know during the meeting or tell the chairs at the end of the meeting. If you don't want to discuss that IPR, please refrain from speaking, from disclosing the IPR. So minutes will be taken. I will share again the link to the CodeMD page on the chat. We are recording the meeting, so the minutes will be published. They will be available to all. So the recording and the minutes links will be given on the minutes, with the minutes of the meeting on the mailing list, and the attendance will be recorded from the WebEx attendee list. So if you're attending, sharing a desktop with somebody and your name is not appearing here, please let us know and go to the notes on the link that was given on the chat and add your name to the blue sheet list. So the original agenda was published as this. We actually have a request to include a discussion on a new document that was just published, which is a proposed LPWAN architecture. So as you remember, there are a number of times where people said it would be very nice to have an LPWAN architecture. So finally, a draft 0 was published, and Alexander will discuss this draft today. So we'll insert 15 minutes after the SHIC over LoRaWAN discussion and before the CoOp over SHIC. If you want to look at the minutes, you will see the updating proposed agenda. So the milestones have not changed since last time. So we have this new document, which when I picked the picture did not appear because it was just published on the LPWAN architecture. Well, we had a to-do last time to request a meeting for IETF 110. So that was done. And so please review the way we asked it. So basically we asked for a duration of 1 hour. The room size doesn't make much sense anyway because it's Mitico, but we said 30. And then we provided the constraints as proposed here. As you can see, NetMod and Interim are in level 1 constraints. And then because of our attendance from Americas, I also requested to make it late, but I guess that every group with an important population from America will also ask for something late, so that won't help a lot. But that's the way I asked for this meeting. And the next discussion will be SHIC over LoRaWAN. Olivier, do you have any news?
No, I'm still working on answering Benjamin Cadduc's comments. There's a lot of them, finally, and it's not all trivial, so it's taking me more time than I expected. And as all 3 last meetings, I'm saying that it should be done this week or next week, but I'm still trying to do it. It's not easy for me these days, but I'm still working on it from time to time, and I do not send email regularly, but I'm still working on the subject.
Okay, that's fine, Olivier. I mean, obviously, we all do what we can, and we all have other constraints. Yeah. So thank you so much. Alexander, I understand that you did not put the slides together with this one, so I will upload the other slides separately. Is that
Yeah.
correct?
Yes. No. I put them, but they are after CoOp.
Okay.
Yes.
Okay. So there you go. I will pass you the ball.
Okay. Thank you. So, hello everyone. Thank you, Pascal. So that was something that we as co-chairs have been discussing from the start of the working group, saying that at some point of time we'll need to, give this big picture of how things will be working together. And we end up publishing RFC 8724, so we have a lot of the baseline principles, and now we think it's long due to have this draft. And we have Anna as a co-author, who has also contributed a lot of ideas and among other things. So that's really the first version, and of course it will evolve over the time. The goal of the document is, so what we have today is we have this the generic framework, so RFC 8724. We have the technology specific documents. We have the Yang data model coming in the OEM, and other ideas on the table, like how do we do SHIC over PPP. So these are give different bricks, and from the CoOp draft, there were a lot of questions about, okay, how do all these things work together? So how are context provisioned, and during the discussions with, so there were Olivier, and we had some questions about in the working of LoRaWAN, how do we, reset some parameters, or how do we recalculate the IID and error handling and all that, right? And these things, in our opinion, they need to be handled there need to be a framework, right? There need to be some reference architecture in which all these questions have their place, and that we don't have half an answer in that draft and half an answer in that other draft, and then we end up with a lot of technology pieces that don't end up to something working. So that will be the goal of that document. and here the point is, right, we publish a first version, but the point will be that this is driven by the use cases and by the design goals that we all define together. So here in this really very, very first version, it's we just try to define the entities. So what are the things that participate in that architecture? What interfaces are there, and what protocols can we imagine for that? And of course, next steps would be, and that might be even in a different document, what message flows and all that. So that will be up to the group to decide. So with no further ado, let's go to the first element is what we learned from the SHIC core and the CoOp and all the discussions with the ISG and with the need to go further in the security considerations, right? Well, the first thing is that, as we've always been saying, SHIC can be on different levels. So there is the SHIC on the network layer, SHIC on the application layer, but also when we look into OSCore, there is actually in the application layer, you can have SHIC on on the outside and within the encrypted payload. Well, that's an example, right? For OSCore, very specific example. We can apply SHIC before the encryption and after the encryption. So we have SHIC on all these places, and so that architecture, the way we provision the context and all that, that needs to fit these different use cases, right? Or we may decide, well, for one SHIC we'll have one architecture, from the other we'll have different architecture, right? But we need to spell this one out. Also don't hesitate to interrupt me in case you have any questions. Right?
So one question here.
Yes.
Terminology-wise, is there a difference between uppercase SHIC and lowercase SHIC? Like you have the lowercase SHIC at the network layer and uppercase SHIC at the application layer?
No. It's just
Sorry.
That was taken from the OSCORE draft. So
yeah.
For me, not, but maybe Laurent has or Anna has input on that.
OSCORE was focusing on the application chic, so the other one was in lower cases.
Okay. Okay. Thanks.
This figure was taken from the CoOp draft, and it's the scenario for the use of OSCORE, how we can use chic with OSCORE. And what we are saying is that it's in the layer 7 than in the application layer. And that's why we put UDP, IPv6, chic, and LPWAN in lowercase, because it's another instance of chic.
Okay. So in this case, for this presentation, the overall architecture, there's no fundamental difference.
No, it's not fundamental here, because the idea is, well, we have 3 instances of chic, and if there is a difference or not, and how they will work together.
Okay.
Anna, it's not necessarily usual for people to see lowercase and uppercase mixed and meaning different sessions. So I'd suggest we homogenize to classical uppercase.
Yes.
Carlos. So yeah, I mean, we have these different. These are not always on the OSI level, right?
Yeah,
okay. Let me try something.
In the meanwhile, hello guys, it's Edgar coming back after a long time.
Yes, Edgar, pleased to see you.
Thank you. I have another comment because I see that this is kind of the discussion seems to be directed mainly to OSCORE, and actually I have been discussing with our product unit, and there are other cases where similar things could happen. For example, with the TSL, you could have encryption before TSL, and then after TSL also have chic. So then I think that's the same principle. So I don't think it is only about OSCORE. It's in general. Wherever you have the encryption, you could have this situation as well.
Mm. Yeah. Yes, definitely. So good point, Edgar. Thank you for this one. So we can include it as a use case, right? To say, okay, well, what are the use cases that need to be covered by this architecture? Is it better like this? Do you see?
Much
yes.
better.
Okay. Oh, moved closer to the Wi-Fi. So we have these different instances. So the first thing is basically the boundaries are not explicitly on the OSI layers, right? We can have one chic instance that is, for example, compressing IP and UDP plus doing fragmentation. Then another instance working on OSCORE outer and another in OSCORE inner. So you see that there could be completely different instances on the same level, on the same layer from the OSI perspective. Or it could be the same chic instance doing all that, right? So but let's say that, okay, they can be on the different layers, and each of them has potentially a set of rules that are different, and they could be managed by different entities. So typically, if we have the network layer, it can be managed by one entity with one set of rules, and the application layer, chic, could be managed, and there could be rules handled by a different entity. So that's something that I think that we need to have in mind when we define the architecture. And let's start really simple, right? Let's start really simple and say, okay, what are the entities? Well, we have the device side,
and then we have the core network side. Here we are not talking specifically about which gateway on which level, right? We just say, okay, well, there is the device, there is the core of the application, and then you have the compression and fragmentation and reassembly and the compression. And there are the set of rules. So the R is the set of rules, and like the compressors and like the SHIC instances are reading the rules from the rule set.
Why did you put the application next to the core and not in another block?
Yeah, so that's a good question. It's just because that's like a very high-level representation. So it's basically that should be considered OR. So it's the device talking to the core, like to the network gateway, or it could be the application on the device. So let's say the host core, the CoOp host core, talking to the application that is in the cloud.
Okay.
So probably, it's for lack of just saying A and B, like the two endpoints talking to each other. That would be on a different OSC layers. And so questions are like, how do these two discover each other? How do they stay in sync? So these are things that we need to answer in this architecture. That the architecture needs to cover, right? That it needs to make it possible. Now, if we do a zoom on that, we can say that the minimal and very simple way of actually doing that is, well, we have the compressor, the SHIC compressor, the compressor in the lower. Do you see my pointer actually? If I move my pointer like this.
No point. No.
Oh.
So you have to draw.
Okay, let me highlight her. Okay, so here of course this is the SHIC compressor, the compressor, right? It reads the rules from the rule set, and then there is this entity that we may say that's a rule manager, and that rule manager has it is the one that this entity that goes and reads and creates and updates or deletes rules from the rule set that are in the rule store. And that rule manager then can have this interface, this network interface or this management interface that it supports this management protocol. And here the most natural way of looking at that is using CoreConf, which is of the family of NetConf and RESTConf. It uses Yang as a data model, so everything just works out of the box. And we do have NetConf and RESTConf, which are widely deployed. So this protocol is used to communicate with the rule manager, and then the rule manager performs the operations to write in the rule store, and the SHIC instance just consults it. So the rule manager in that perspective, so two rule managers, they work in pairs. So if we say that the device in the core or device in the cloud, there are rule managers on both ends. And high-level requirements or high-level design choices are, we have the SHIC model representation done in Yang. In the protocol, from the protocol selection, we can have many different protocols. The CoreConf is the one that seems like the native one, because it's Yang native, it uses CoOp, it uses CBOR, so it's really quite efficient. But there could be others, like as we have the example with the PPP draft. There, we have the protocol for PPP session negotiation that's used between the two entities that could be looked at as rule session managers, right? Rule managers. So from that perspective, we have the rule managers, we have the interfaces that the two of them, communicate. And then going a little bit further in the definition of that architecture is the rule managers. They have IP addresses by default, of course. So if we are working on a network level SHIC, these can be local IPv6 addresses, or if we are looking on an application level SHIC, then that can be global IPv6 addresses. And that way, of course, they can be, they can communicate over IP, over the SHIC instances. And just a short note, in some cases, these could be co-located. They can reuse the application level protocol. So, for example, if you have a application level SHIC that compresses CoOp traffic, for some CoOp application, that could be, that there could be, it could be the rule manager could reuse the same CoOp server, and so it can have like just the endpoint that can be used as communication between the two. And on the security-wise, so this is how both rule managers are able to communicate to each other. And on the security-wise, well, there is a choice, of course, but we can simplify the things and say, well, on the network level SHIC, if the layer 2 encryption and the layer 2 security is deemed sufficient, then maybe we don't need additional security. Or we can say, well, we need end-to-end encryption or end-to-end security for application level SHIC. As with, OSCORE, if we are doing between in CoreConf, it could be CoreConf over CoOp over DTLS, or it can be CoreConf or OSCORE CoOp. So that's up to the final design.
But Alex, is it about the rule manager or at the actual traffic which go on the SHIC?
Well, that's about it's about the protocol. Let's say it's about the protocol that allows the two rule managers to communicate.
Okay.
So to secure that traffic.
Okay.
Then there could be additional. Yeah, but here it's this part. And that last point, I think I already mentioned. The rule manager protocol goes through the SHIC compression, and the compression could go through the SHIC, compressing the compressor. Let me just give you an example. So this is an example of a network level SHIC. So here we have both ends. Let's say that left-hand side is the device, and right-hand side is the core. Here we have the SHIC compressors and the compressors. And here we have the LPWAN link. So the application is talking through the IP stack, through the SHIC instance here, over to the other SHIC instance, through the IP stack to the other application side. Well, that's really nice. The SHIC compressor and the compressor, uses the rules that are in the rule store. And now what we have is that the rule managers can communicate through their management protocol, for example, CoreConf or OSCORE, can communicate to each other. And that communication actually could go through, as I said before, if they're on the same, so it's a network level, so they could be using link local IPv6 addresses. So each of them has a link local IPv6 address. These IPv6 addresses can be discovered, can be provisioned in advance, can be defined, to be generated in a static way. I mean, the link locals, of course, they are known, but the destination port and all that, all the rendezvous point can be fixed. And so, the first rule manager communicates over the IP stack, then it goes over the SHIC instance, all the way to the other IP stack, and then up to the rule manager. So they have like this communication, the protocol exchange between the two rule managers. And then, CoreConf, it's like NetConf. You can have all the configuration, all the operations that are necessary there, and then the rule managers can perform CRUD operations to the rule stores on both sides, to ensure that they are synchronized. So I think that's that these are the couple of examples, and Next, so there are a couple of points. Next, there are some. We need to find which other use cases we would like to cover by this architecture. Discuss about how to express the entities and just generally have this input of what kind of interfaces, what kind of entities, what kind of protocols, all that. But and then we can go into like the different stages of the network, message flows, and all that. And probably others. So that's in a couple of words. And yes, if you have any other questions with Anna and Pascal, we're happy to answer. Yes.
There are two very special cases that I have in mind that probably we want to discuss separately. Can you come back to the previous slide, please? So yes, in one example, which is the device which is shipping with all the rules provisioned, and basically the device number or something will give you what rules it has, and maybe it will not communicate for a long time with its rule manager. Then it might be that the communication on the left is not synchronous, versus the communication on the right could be synchronous with the rule manager, right? But it might be that the rule manager to the device is actually done early, right?
So communication on the left, you mean?
Between the rule manager and the device, if the device is somewhere, in the field,
yes.
maybe it's not communicating to its rule manager. It has been provisioned by the rule manager, but now it stays there. The rule manager knows how it configured the device, but it cannot. It does not do it. You cannot have a synchronous flow between the four parties, two devices and two rule managers, right?
Yeah. So actually, yeah, I see. Because I added this schema the last moment. Here, actually, this is the device. Let's say these are all on the device side. So there is some kind of a rule manager on the device.
Okay, which is a cache of the big rule manager which provisioned all the devices or something. Exactly.
And this, yes, and this is where we were discussing, and this is where the point that maybe when it shows up the device, it can send an operation to the other rule manager to say, hey, well, go do a DNS operation, or fetch the rules from that URL. And
I can see. But we need to describe that, because otherwise it does not meet the eye. The other thing the other case, which is yet another variation of what we see here, is the SHIC over PPP draft, where the assumption is that neither side starts with the knowledge of the rule, but the compressor will find somehow a URL of the rule manager where the rule manager has positioned. So it's not really the rule manager, it's the rule itself on the URL. So there will be a relation between a server which provides the rules and the rule managers on both sides, which basically the left side discovers the device and fetches the rules from the URL of the rules from the rule manager, and then fetches the rules themselves from a URL, and then it tells, as it creates the PPP session in the PPP headers, where it describes the compression, it tells where the URL is for the compression rules, so that the other side can go and fetch the same rules at the same URL. And the expectation is probably that URL can be local. For instance, if you have a control loop inside a factory network, they don't necessarily connect that to the internet. So it could be that the rule managers and the rule server are all kind of collocated in the control network. But we make this distinction between the rule manager on each side and the rule server, which is just the storage of the rules, so that both sides will use the same URL. So we know they will both fetch the same rules.
Yes. So basically, that's what that means is, if I understand correctly, and I think that works really well, is to have like a third rule manager that actually configures both rule managers on the device here, on the left-hand side and on the core.
Could be, but there is this entity that doesn't really show, which is the actual storage for all those rules. And the way, and I had to do it because of the way PPP passes data for the compressor. It was really nice to be able to just share a URL as opposed to passing all the rules. There is this expectation that there are two entities. One is really the logic, which says, you pick those rules, blah. And the other piece is just the main storage of those rules, like the repository of the rules. It's kind of separate. And the cool thing about having a URL for the rule is that a URL that, it's unique. And you want to be sure that both ends will use the same data for compression and decompression. And they don't, use the different rules. You want to fetch them at the same place, or at least with the same name. Even if the resources is stored at two different places, the name of the resource makes it so that you recognize it's the same resource.
Yeah, but I perfectly agree with you that it was not. I mean, that is a use case that that can be covered with this architecture, but it needs to be, developed a little bit further.
Yes, that's what I meant. I mean, we need to differentiate that with the most common use cases that we have today.
Exactly. So yeah, I mean, we really wanted to get the ball rolling because, as I said, we'll be talking about this, and we got a lot of comments for the CoOp SHIC over CoOp, CoOp over SHIC draft that were basically saying, "Hey guys, how do you do that? How do you do that?" And that's right, the first stone of this one. And as Pascal said, cover the at least say if you have other use cases, or how do you feel about this approach?
So one general comment I would have is that now, after hearing your presentation, it cleared my mind. I was a little confused with the title, and I'm afraid that it could happen to other people, because in RFC 8724, the generic framework, we do have a section 3 that is called LPWAN architecture. So, in this case, a SHIC architecture, and I was a little confused about what exactly we were saying, because we had already presented an architecture. Now it's clear to me that it's two different things, but probably there should be some explanation or some mapping explaining how that was a basic network architecture, and this one is expanding this basic architecture to include the new functionality that has to be introduced after. Or something like that.
Oh, yes, that we'll need to clarify the title, and as I said, it's a first version, and the point was to get the discussion going and to see what, is it going in the right direction? And
I personally think it adds value, and it's going in the right direction. And again, it's just more the title so that we understand this.
Do you prefer
happened with
framework instead of architecture?
But framework was the title of it before.
Well, it really depends on what we want to put in this document, but I believe we need architecture and framework. It's usual now. I'm seeing that in many places, but you need the architecture to position the objects. Like, you need to describe what this rule manager is about. If we have a rule store, we need to explain what it is. Then we need to position which object talk to which object and when. And all this is architecture.
Right. It's probably more a functional architecture than a
yes, and then
network.
once we've done that, we can explain those things in more details, which could be framework. But there is an architecture piece that's missing. And I was talking to Alexander, and if you remember, maybe you've seen it, maybe not, we published a document in the IEEE, and both at the IEEE and IETF journal, pretty much in 3 months interval, about the time when we formed this working group. And we actually described an architecture in there. And I believe that the text or the general, we need to adapt it to, because things have changed, but we need to bring that back. We need to explain, for instance, the discussion about where you have a crypto, you've got a separation of endpoints, and you've got a separation of rules, etc., etc. This is architecture. This is not framework. So we need that, and it's not in 8724. I mean, that's missing, and that really caused a lot of hassle, in particular for the CoOp document, where actually it was one ISG review which pointed out that having those 2 different stages of SHIC was a major architectural point. And since we didn't have an architecture, I didn't show anywhere.
Yeah, so at least we could say that it's extending the original architecture. It could be an extended architecture.
Yeah, there are some basic architecture considerations in 8724, but 8724 is mostly scoped to do a compression, not to explain what an LPWAN network is. And here we need to position SHIC in the middle of many other components and many other protocols.
I agree, and again, I think it adds value and it's needed. I just feel that it shouldn't be called the same, so that we don't work completely.
So, the protocols themselves, etc., that's architectural, and that can be called framework. But the actual components and how they relate and the abstract exchange they have, that's architecture. Okay, so yes, let's call it, if you don't mind, and for now it doesn't deserve the name, but let's call it architecture and framework so we know what we expect to do in there. That's my suggestion, right? As an early co-author. We don't want to have 2 documents either. It's very hard at some point to say, oh, this is purely architecture and that's purely framework. That's very hard. And we don't want to throw 2 documents at the ISG. On the other hand, we want to have this one early enough because it's already too late. I mean, we already suffered in some reviews because we did not have it. Okay. So thank you, Juan Carlos. And every contribution is welcome. That's another thing.
Yes. And thanks also, Edgar, for pointing out TLS. So if you have, we are really welcome to having other use cases or points to include. And the point would be, to have in this document to have at least pointers or to give the big picture, or as much as we can, of course, to the details, but at least the big picture of, okay, how are all the questions that we all have for some time, how are they handled? And when a device goes into a network, well, there are certain things to be done, and all that, we need to position right now so that we have a shared vision on it.
I'm sorry, since we are at it and we are talking to Edgar. Edgar, can I have a quick question to you, because I'm happy to see you. But we kind of had a to-do from last time to find some help to quote unquote replace you, because we thought that you were no more with us. So I'm very happy to see you, and I wonder if you plan to have time to work with Anna on the 5G document, or if it was just by chance that we had you today.
Well, the plan is that I will try to help bringing up the latest things missing. hopefully I can continue. It's not yet fully agreed with my manager, but then I'm also looking for some support from the product people to see if we can actually rise the profile of SIG in general. So maybe try to see if we can bring it to 3GPP and so on, because they haven't been so far much interest. But then now that there are some concrete use cases for it, then maybe the story will be different.
Okay, so that's really excellent news, Edgar. So we're placing on hold actually the request that we had to find some help to quote unquote replace you, and we consider that it's still you doing the job until you tell us that it won't be, right? Sure,
let's do like that.
Pascal, for the milestones, we were talking with Edgar this morning, and we think that the early 22 is better.
You think that what, sorry?
For the first quarter of 22 is better, the milestone from the NB-IoT draft.
Let me write a to-do. So if you go to the minutes, you will find we have a number of to-dos.
I will put there if you want.
Yeah, I'm doing it already, but change the NB-IoT target date to early 22. Pretty much. So first, I mean, basically spring 2022, like February, March?
Yes.
Okay. So.
Thank you.
Okay, and so I'm placing on hold actually. Okay, I'm writing that it's the finding a replacement is on hold.
You can put that Edgar is irreplaceable.
Yeah, I think.
So Juan Carlos, there was also the same to do for you actually, to give us the date.
To replace me?
No. To give us a date for the six-pack document. You're irreplaceable, Juan Carlos.
Well, I think last time we had mentioned that we were planning to, or we were targeting to do last call spring, and sorry to get it finalized by, let's say, fall, to be more realistic.
Fall.
Yeah.
Fall 2021. Okay. Mm-hmm. So Laurent was to refresh the model draft. Did you have a chance to push it, Laurent?
No. In fact, I have made some updates, but I think that I can push a version very similar to this one because it's quite good, and I need comments. And now that Young is popular, and I can have feedback on it.
We were to help you find a young doctor, and I must say that I did nothing for that. I don't know if Eric did something.
No, but I will publish this week or next week the new version 4, I think, of the document.
Okay, so I'm moving the to-do from last week to this week.
Yeah.
Juan Carlos is done for 2022. Okay. The last to-do was to request the meeting for IETF 110 and place netmod as conflict, which I did. Okay, so we are done with the to-do, which is pretty good. And actually, something, because we still did not discuss CoOp over SHIC, but
yes.
There's something else to mention before we go?
No, it was that. So we'll be working on the architecture document, and we consider this to be our job as chairs from the start with Pascal, and the point would be that it takes all the considerations from the working group. So please don't hesitate to give your feedback and to actively propose or criticize the text as it is. And yes, so there was maybe a final thing. I announced that on the mailing list, but I just wanted to make that clear out here as well. So chair hat off. Of course, there might be some IPR or factio in part of the section of that document, and of course, should we get further on, it will all be under the standard acceptable IETF licensing rules. So that's it.
Okay, so we are mostly through. I kind of moved in the tentative agenda the fact that actually the LPWAN architecture document took us more time than initially expected, so it was 25 minutes. But we still have 5-10 minutes to discuss CoOp over SCHC. And now, if you have any news for us?
Okay, I answered to Benjamin, but I didn't publish 17 because I want to discuss with him, but he never answered to my mail. So I think that we are. I received Eric's mail with the Word format, and I passed the Grammarly to correct the English more. So I have done a lot of corrections. We are almost done to publish 17. So I was, my planning was that as I didn't receive an answer from Benjamin, I think that I will publish 17 and I will resend him a mail. But just before the meeting, I saw the mail from Eric about the security tutorials you sent to us. I'm afraid they are thinking in the same way because these security tutorials are for compression, data compression, and not header compression. I don't know if they are valid for what we are doing because we are not doing data compression as deflate or zip or whatever. We are doing header compression with the logic and the analysis of how it's going on the data in the header. So
and exactly, Anna, that's exactly what I wanted to say by sending you the document.
Yeah.
It's not so much about header or data, by the way. It's simply if you are using something like gzip or anything which is zip compression, then you are open to something because you exchange dynamic dictionaries, kind of, which is not the case with SCHC. So this attack does not fly. It's not able. So it's basically comforting the message that, yeah, this attack does not happen with SCHC.
Okay. So SCHC is not as just zip or deflate. It's really a header compression looking for the logic of what we are sending and trying to reduce redundancy. But never trying to compress data for the packet. Or the packet as data.
Okay, Anna. So, I agree with your idea that you should publish 17. I mean, you see the way Benjamin works is he picks the specs, he does his review, but then he will pick another one and do a round robin, and so your answer will be placed in a queue, and he will handle everything that was in that queue before it comes to you. So is the way he operates might be efficient, but it creates a latency between the question and the answer, basically. And I admire him to still remember what the question was at the time he processes the answer. But fact is, it's much better that you have published because you can basically send him in your response, here is the diff, and you give him the URL of the diff or something. You say publish 17, and it was just for you, so all the diffs that are there are for you, or something. And then when he processes that will be a lot easier and faster for him because he has to reload the full context of his previous review.
Okay, I do it.
Nice, thank you.
So I don't have any more information for this draft.
Okay, so that takes us to the open bar and AOB, any other business. Anybody pays the drink for everybody or anything like that?
Yes.
Good. I want some meat.
You want to stir? Okay.
And tomorrow I'm with you, Laurent. Actually,
really?
Rennes.
Not really. There is no snow on the.
Well, here I could see snow actually, but now it's melting. Yes, it's almost gone.
Okay, just one point with Dominique. I don't know if you got him and you talk about that, but we are working on before the CoOp on the OAM draft.
Okay.
And I think we will have something very, very soon.
Nice. Okay. Actually, Dominique will listen to the recording that I made this time.
So you made a very, very good job.
Looking forward. Okay, that's nice. So thank you all for this very productive meeting. I really loved it. It was a very nice meeting. I will update the target dates for the two SHIC overflow documents. And I guess we meet in 2 weeks now. Thank you again for being with us and for all the work that's being done in this working group.
Yes. Thank you all.
Thanks, everyone.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Thank you.
Bye.
Bye.